Alright, it's time to take a look at negative exponents. As long as you know your exponent properties, negatives are not too tricky. But some of these problems seem a little complicated, but you got to look at it as there is only one thing you need to know about negative exponents. Example, x to the negative 2 means 1 over x squared. Or, in general, x to the negative a equals 1 over x to the a. So a negative exponent simply means you reciprocate the expression. You reciprocate it. Or you can just say you flip it over. So x to the negative 2 becomes 1 over x squared. Alright, that is it. That's the only property. However, once we start combining things, you'll see it gets a little complicated. So we'll gradually build here. If we had x to the negative 1, that's 1 over x to the 1, or 1 over x. Okay, let's go to a few more examples. Basic examples. 2x to the negative 2. Now notice the negative 2 exponent does not apply to the number 2. It's only on the x. This is where some people get confused. They'll try to flip the 2. So the 2 stays on top. The x to the negative 2 flips to the bottom. Once it flips, the negative exponent goes away. Let's try another one. How about x over x to the negative 2? Uh-oh, this time we have the negative power on the bottom. So, same rule applies. It reciprocates or flips, so the x to the negative 2 flips to the top. So he joins his partner up there, the other x. Now you can use your property of exponents where for multiplying like bases, we add the powers and the final answer is x to the third. Alright, so let's keep building here. Let's get a new page. Come down. There we go. Alright, let's switch colors. Let's go red. Alright, how about 1 over x to the third to the negative 2? Alright, the negative 2 power, it really, again, doesn't matter what that power is being applied to. This is the same as, let's go off to the side, it's the same as a to the negative 2. You would flip it to 1 over a squared. So in other words, whatever the base is, so our example here, a is the base, it gets flipped and the power becomes positive. So in this example, 1 over x cubed to the negative 2, the base, 1 over x cubed, flips to x cubed over 1, and the negative power goes away. Now the 1 is not necessary, so we'll just write it as x cubed to the 2 and apply our property and get x to the 6th. Another example, x to the negative 3 to the negative 4. Now when you have problems where you have more than one negative exponent, what I would like to advise is try to, as your first step, try to get rid of as many negative exponents as possible. Now there's several different ways to do this problem, but if you take a look at it, you have a negative 3 and a negative 4, use your power to a power property and multiply those together, you can get x to the positive 12, and you're done. All the negative powers went away. Now, to make this more complicated, I'm going to show you, you could have done this. You could have flipped the x to the negative third. Eraser. Come here, eraser. There we go. X to the negative third. I flipped it to 1 over x to the third. Haven't messed with the negative 4 yet. Alright, now the negative 4 power means you reciprocate the base again. So it's x to the third over 1 to the positive 4. Now I apply the power property, and you get the same answer, but it just took a little bit longer. A little more confusing too with the extra steps in there. So again, I advise try to get rid of as many negative powers as we can. We'll have a more complicated one in just 1 second. Let me call that example number 1, number 2. Example number 3, let's take a number, 2/3, and raise it to the negative 2 power. Well, again, negative power means reciprocate the base, so the 2/3 becomes 3/2. Reciprocate, the negative power goes away, apply the power, 3 squared is 9, 2 squared is 4, final answer 9/4. Okay, a little more complicated. Now now it's time for the big time. Let's go with this problem. We're going to have several negatives, some positive powers, and we're going to put all this to the negative 2 power. Okay, again, what I advise, if you apply the power to the power property, it's going to get rid of several negatives at once. In other words, this negative 2 power, since it's outside the parentheses, we're going to multiply it times each of those individual powers. So x squared to the negative 2 becomes x to the negative 4. Y to the negative 3 to the negative 2 becomes y to the positive 6. Denominator, x to the negative 3 to the negative 2 becomes x to the positive 6. Y to the negative 2 to the negative 2, y to the 4th. All right, now what we did, we got rid of several negative powers. We only have one negative power left. Any negative power gets flipped. So this one is going to move down there. Everything else stays where it's at. So that x to the 6, I'm just going to write everything where it was. And now I'm going to bring down that x to the negative 4 and write it as x to the positive 4. So the top is y to the 6th. The bottom is now x to the 10th, applying the power property, y to the 4th. One more power property, we have y to the 6th over y to the 4th. So we subtract those powers and end up with y to the 2 over x to the 10. Took a long ways to get there, but yes, that is the final answer. Let's pause for just a second and we'll move on to another example. Okay, I've got one of the most complicated examples, number 5, set up, ready to go. And if we just take it one little step at a time, we'll be fine and get the right answer. So let's just take a look at this in little pieces. We're going to take a look at this piece of the puzzle. And what we're going to do is, like we did in the last problem, take the negative 2 exponent that's on the outside and multiply it by both of the exponents on the inside. So it becomes x to the positive 2, y to the positive 6. Well, that was pretty easy. Now let's move on to the second part of the problem and do basically the same thing. Take the negative 2 power on the outside and apply it to each power on the inside. So the x becomes x to the negative 2, y becomes a positive 8. On the bottom, the x becomes a positive 6. Alright, you want to keep going. Don't try any cancellation yet. You want to try to get rid of all the negative powers before you start canceling. So the x to the negative 2, I'm going to move down to the bottom and make it x to the positive 2. So let's start just lining things out to make this go a little bit faster. So the problem now becomes the first set of parentheses, x squared over y to the 6th. The second set of parentheses, y to the 8 on top, x to the 8th on the bottom. Now we can do a little cancellation. We're going to use our power properties without, well, let's try skipping few steps here. The y to the 8th over y to the 6th, they don't have to be all put together. I mean, let's put this step in. I'll show you what I'm talking about. X to the 2nd, y to the 8th on top, x to the 8th, y to the 6th on the bottom. Cancel. Now notice here on the x's, x to the 2nd, x to the 8th, if you subtract those powers, the top power minus the bottom power, you end up with x to the negative 6th. And the y's become y to the positive 2. Now, the x to the negative 6, using the single negative exponent property, flips to the bottom and becomes y to the 2nd over x to the 6th. But as you get good with this, you can start skipping a few steps. Let's go back to this circled part of the problem. What I say to do is, when you subtract those exponents, 2 minus 8 is negative 6, or 8 minus 2 is 6, you put the exponent on the part of the fraction that has the higher power. In other words, x to the 8th is a higher power than x to the 2nd, so 8 minus 2 is 6. So the x to the 6th you know is going to end up on the bottom, and same way with the y's. The 8 is higher than the 6, so they end up where the higher exponent is. That way you don't have to do those final little steps. You can just kind of skip steps and go straight to the answer. Alright, let's take a look at one more fairly complicated problem, and then we'll consider us as mastering negative exponents. Alright, clean page. How about negative 20 m squared v, let's get away from x's and y's for a minute, negative v cubed over 5 times negative v, quantity, squared, negative m to the fourth. Now this one didn't have any negative powers in it, but what I threw in there were some negative quantities on the variables, the negative v, the negative m, just to show you the difference between negative powers and negative signs on variables. Some students will get confused on that. So we're not going to switch anything. Don't think you flip anything because there are no negative powers. So let's just simply go straight across with the numerator. M squared v. I'm just going to kind of drop the parentheses. Now negative v cubed, think of that as negative 1v cubed, because that's exactly what it is. And a negative number raised to an odd power will give you a negative number. So that becomes negative v cubed. Likewise on the bottom, 5, just leave it there for now. Negative v squared, we have an even exponent, so that becomes positive v squared. Now, a little tricky again, the m, the 4 is on the m. The 4 does not apply to the power, meaning the 4 rather does not apply to the negative sign. In other words, there's a difference between this not equal to this. Okay, on the right hand side, the 4 applies to the negative sign. It's like negative 1 to the fourth, which is positive 1. On this side, the left side, the 4 does not apply to the negative sign. It does not apply to it because the m would have to be, the entire expression would have to be in parentheses. So let's go back and finish this. As I said, it's like a negative 1 being in front of the m, but the negative 1 is not being raised to the power, so that's just going to be negative m to the fourth. Let's get our signs straightened out. On the top we have a negative 20 times a negative v, so that becomes a positive 20 m squared, and then we have v times v cubed, which is v to the fourth. On the bottom we're going to end up with one negative sign, so we'll stick it out in front of the 5, and we have v squared m to the fourth. And now let's just do our one thing at a time. First we do the numbers. 20 over negative 5 is negative 4. Let's do the m's. We have m to the 2, m to the fourth. We subtract the powers and get a 2, and we put them where there were more in the beginning, which is on the bottom. The v's, v to the fourth over v squared. We subtract the powers. 4 minus 2 is 2. Again, you put them where there were more, which is on the top. And yes, that is the final answer. So watch the difference between negative powers and negative variables being raised to positive powers. So it's just a matter of knowing 4 basic exponent properties and just being very careful as you apply those properties to each problem. Alright, negative exponents, done.